So, like I said, we're going to talk a little bit about different parts of the microscope here. So we're going to go through that and label that for you. So let's see. Numero uno here. Number one. So it doesn't matter where you write. Well, obviously you write it down beside there, I guess. But we're also going to have to write a few things down here as well. So this is number one, of course, is the eyepiece. It's the part you look through. It normally has a 10 times magnification. Make sure we know that. That's probably important. Okay, the tube. So this holds the eyepiece. Good. Okay. 3 is the arm. It connects the base and the tube. And it's also how we carry the microscope, correct? You know this. Sure. All right, so that's the arm. It connects the base and the tube. Okay. Next. Oh, that's number 4, obviously. That's called the coarse adjustment knob. We're going to only use this on low power, okay, objective lens. So remember, this only happens with low power. So keep that in mind. This is this one right here, coarse adjustment knob, okay? From the coarse adjustment knob there, we're going to go to the fine adjustment knob, which is number 5 there. I know it's kind of cut off here. This is the one you're going to use with medium and high power. And this is important because when we go to look at these, actually, I'm going to let you copy first here because you're not going to pay attention to me. So fine adjustment knob, we're going to use this only on medium and high power, okay? Once it's in focus with the lowest one, the big knob here, we're going to use this to make little adjustments, okay? And that's important because if we start messing around with this, what's going to happen is we're going to lose what we're looking at here because they're incredibly tiny. So it's really important that you just kind of like get it in focus. I'm going to give you a little tip with that as well before we go to the lab and do that. But I think that's what we're going to do anyway. I don't really want to do a video of that. So, but I'm going to give you a little tip as well on what to do there to make sure you don't lose what you're looking at. Because of course, when you start zooming in, if you're not zooming in exactly in the center, you're gonna, even if it's over here a little bit, as you start to zoom in, you might see it here, but as you start to zoom in, if you're not quite centered, you're gonna miss it, okay? And then you're gonna be like, where did it go? I don't see anything. And of course, because you zoomed in on the wrong spot, right? So just kind of keep that in mind, all right? Let's keep moving here. 6 is the base. Hold this and the arm to carry the microscope. So we're going to use 3 and 6 there, or the arm and the base to carry the microscope. Yep. Okay. Revolving nose piece. So basically, this just kind of turns it around. I think so. Okay. Objective lenses. These are the ones that we're going to flip between. Okay. So there's what we call a low, medium, and high. These help magnify the object. The magnifying power is engraved on the side. All right. So objective lenses, you can switch between. There's 3, of course. I think the lowest is 4.5, and I think it goes to 10 and 100, if I'm not mistaken. I could be wrong about that on ours. We'll talk about that though. But I think that's what they are. And they can have different. They can be different as well, depending on. Stage clips, so this is used to secure the slide. So usually we put the slide underneath these little clips here to make sure we hold the slide in place so it doesn't move around and so that we can kind of keep that where that object is consistent. Okay. Stage clips, good, yes. Stage clips. 11 is the stage. It supports the microscope slide, of course. That's where all the magic happens. The stage. 11 is the diaphragm. This controls the amount of light reaching the object being viewed. That's right underneath the stage. It's going to have a little metal tab on it that you can kind of turn, and it'll adjust how much light gets to the slide. That's actually important because sometimes too much light, it'll kind of drain out the cell. You can't see it as well. And not enough light, you're going to find that it's too dark and you can't see anything either. So you may have to play with that a little bit as well, the diaphragm there. Okay. And finally, the light source. This illuminates the object being viewed. Okay, so that's actually the light. When you plug it in, turn it on, that's the light you're going to see at the bottom, and that's what allows. And again, you control the amount of light, well, in two ways actually on ours, which we'll talk about right away here. But that is the light source. Okay. Okay. On the microscopes that we have, just so you know, they're on the back side here. So on the back side of this arm here, there's going to be a power switch here, okay, somewhere there. So you're going to have to obviously make sure it's turned on first. Okay, plug it in, turn it on. So that's part of it. First of all, if you plug it in, turn it on, and nothing really happens or you don't see anything, there is another dial. I don't know what side it is on. I think it's on the other side. But there is basically a dial here that you're going to see somewhere there, okay? And that dial basically turns up and turns down the amount of light as well. So the bulb is kind of like a, what do you call it, like a dimmer switch kind of thing. So there's a dial that you can kind of roll. So I would say after you turn it on, you don't see anything, try that dial to see if anything else happens with that, okay? Roll it up or roll it down and see if, and it shows on you there. It's got one of these things, like where it's kind of like that. And of course, this, if you're down, you know, if you roll the dial looks like that. If you roll it that way, it'd be dimmer, and if you roll it that way, it'd be brighter. Yes. So just try that as well, just to make sure. Okay. So there's that. All right. Is that good? Okay. So power switch and that. Then there's two other things that you don't see on this one that we have as well. Now you don't have to use these, but I would suggest maybe doing that. There's two knobs that kind of are right around this area here somewhere. I forget, I think they're right here. And there's two knobs and they're kind of on top of each other. And what they do is they basically move the slide around. So on low power, when you first look through here, on the lowest power, whatever that is, let's say it's this one here, on low power, you want to use those two knobs, basically, to kind of move the slide. If you turn one, it's going to go this way, back and forth. And so it's going to go horizontally. And if you turn the other one below it, it's going to go this way, up and down kind of thing. And of course, the first thing you need to do is you need to look through the eyepiece and find your object, right? And focus it. So the first thing you're going to do is put the slide in here, make sure it's attached securely so that you can, so it's not going to move on you. And then, once you got this slide in here and it's attached securely, you need to find it through the low power, yes? And to do that, you're going to use the focus knob, and you're also going to look through there and see, you might have to move it up and down, left and right, to kind of find that. And it's kind of opposite, because I don't know if you know this, but the microscope flips everything, right? So it actually flips it. So it's kind of opposite of what you would think. But you're going to have to play around with those two to look at that. The biggest tip I can give you is this. When you look through the eyepiece, okay, and this is super important, because otherwise then you're going to call me and I'm going to be like, well, I don't even see it, first of all. On low power, before you do anything else, the very first thing you need to do is you need to look through the eyepiece here, and you're going to see kind of like a little pointer here. Okay, I call it like a needle. And there's a little needle in there. You're going to see that. Okay, does this sound familiar? Make sure that you organize your, so use these knobs over here, whatever they are right there. Use those knobs or move the slider, move the stage around, and make sure that this is in the center and it's pointing to your, no, that didn't work at all. Make sure it's pointing to your cell that you want to look at, okay? Make sure that that is right on top of the middle of that cell. Because when we switch it to the next power here, so when we turn this, and we're going to use this power now, and flip it to that power, we want to make sure that, hey, I know that that is on top of the cell, so I know it's there, okay? And it's also in the center, and then I can just use the fine knob here to make little fine adjustments with focusing it, okay? We're not going to lose it, because when you zoom in, of course, you're zooming in, and if you're not zooming in exactly in the center, we're going to miss it. We're going to be over here, and then I don't know, and then again, everything's backwards, so we're going to miss it, okay? And then you're going to be like, I can't see anything. Well, of course, because you're not even looking at it anymore. It's moved, okay? So keep that in mind. Always on low power. Make sure you adjust it so this is pointing right at the cell, the one that you want to look at first, okay? And then go from there. Okay, that's super important. Good? Questions? Anyone? First here. It says here magnification. The magnification of a lens tells us how much it appears to increase the size of an object. For example, a magnification of 10 times makes an object appear, of course, 10 times larger than it really is. Okay? In a compound microscope, both the objective object, this should actually say objective lens, and the eyepiece contribute to the magnification. Okay? So both of those things contribute to the overall magnification. The formula, I guess, or if you want to talk about that, is, well, the overall magnification is the eyepiece power, okay, which for us is what? 10 usually, okay, for our lab. Doesn't always have to be, okay, there's different microscopes obviously, but usually it's 10. And we're going to multiply that by the objective lens power, okay? So again, if we go back to the microscope, I'm going to do that now real quick. It's this, which is 10 times magnification, and then whatever number is on here, okay? We multiply those two together. Example, I don't know if this is what it is, but let's say this is 10 times, and this says it's 4 times power. That's 40 times overall. We're making the object 40 times larger than really what it is, okay? 40 times larger. So 10 times 4. This, I think this maybe this is, I don't know. I'm not going to say because I don't remember, but you're going to multiply those two together. That's the overall magnification. Okay. Good. Yeah.
But some like scientific ones have like
probably bigger. Yeah.
Like they would be like 30 in there.
Yeah. Bigger. All right. What's next here? What is the overall magnification of a microscope using a 40 power objective lens and a 2.5 power eyepiece? So let's take a look here. What is the overall magnification of, do that right now real quick. I usually just put that down, just kind of abbreviate it. Overall magnification, okay, is equal to the eyepiece times the objective, right? And it says here we have a 40 power objective lens, so 40 power here, and our eyepiece is 2.5 power, so our overall magnification should be what? 100 times, right, basically. So I'm going to magnify the object 100 times. Okay? Good? Questions, anyone? Okay. Fairly straightforward.
The units are like 100 times.
Just, yeah, it's just 100. Yeah, you're magnifying it 100 times. Okay? Okay. Let's do example 2 as well. Go ahead and start that one. It says, what would be the overall magnification on a microscope tomorrow if you're using a 4 power objective lens instead? So go ahead and do that real quick. All right. So what would the overall magnification, 40 power and 2.5 power eyepiece? So again, overall magnification is the eyepiece times the objective. And in our case here, the eyepiece is what, 2.5 times? Oh, we did this already, eh? And 40 power objective, so 100, okay, 100 times. That was the one we did before. Oh, you got to be kidding me. For our purposes, for our purposes, the eyepiece is always 10. Okay, it'll say that on there, of course. Usually, obviously, they're labeled. No matter what microscope you're using, they're usually labeled. Okay, here we go. I got there eventually. This is the week that what I've been having. What would be the overall magnification of a microscope tomorrow if the objective lens was 4 times? So again, we're talking about the eyepiece and the objective. Okay. Well, again, if we're doing one tomorrow, ours is 10 times, right? So 10, and if the objective lens was 4, we'd have a 40 times overall magnification. Okay. So again, tomorrow we'll use a 10 times eyepiece and a 4 times. Yeah.
So it would be like, you would just use, because they don't specify what like lens you're using, you would just use the 10.
The eyepiece is the 10.
Okay. So
You don't
they
get a
go for
choice.
that.
Yeah, well, for our
Like in the
purposes,
first
yeah.
example, they said
Yeah,
the eyepiece was
yeah, so they give you that specifically, yeah. Yeah. Okay, good. All right. 3, if you want to magnify an object 1,000 times. So if you want to magnify it 1,000 times, what would the magnification of the objective be, given that the eyepiece already has a magnification of that? So again, use the formula, eyepiece times the objective, okay, overall magnification. We want the objective, we want the overall magnification to be 1,000. So we actually know this. The eyepiece has a 10 times, so we know this, and we could solve for the objective, right? What does the objective have to be? 100, right? So we'd say, well, how would I solve for the objective? I'd divide by the eyepiece, divide by the eyepiece, basically kind of thing, right? Or basically say 1,000 times divided by 10 is the objective lens, or the objective lens would be, of course, 100 times in this case. All right. So again, that's just kind of like A equals BC kind of thing, and we were solving for C or something like that, right? So divide both sides by B kind of thing. That's what that is. Okay. Yeah.
So you want us to start with the OM equals I times object?
Yeah, you should at least start with that, so you know that that's kind of what we're looking at for the overall magnification. Yeah. Okay. Good. Questions, anyone? Okay. So that's that part of it. That's the overall magnification. Now we're going to get a little bit more into how much we're actually going to see, something called field of view here. Okay. Before we talk about field of view, we're going to talk a little bit about units again. So a little bit of review about units. Now I know I gave you like a chart, kilo, hecta, deca, what base unit, meters, millimeters was on there, and then we had micrometers on there and things like that. But in biology, because we're looking at things that are incredibly small, we usually talk about 2 things: millimeters and micrometers. Okay, and a micrometer, of course, is 1,000. 1,000 micrometers is 1 millimeter. Yes. So we'll talk a little bit about that coming up here. This is actually a little bit wrong here, so I'm going to fix this right away. Just the units didn't transfer over here. When using a microscope, you will be looking at a very small object, so we need to use an appropriate scale to measure those units. Meters, obviously like a meter stick. Yeah, we're not going to use this, okay? Way too large. So that's good for measuring like distances or something like that. So meters are too large. Even millimeters sometimes are too large, okay? When we look at our first little lab here is going to be like field of view stuff. And when we look at that, you're going to find out that, hey, if I zoom in even a little bit, I'm already between millimeter markings, okay? So it doesn't take very long until we're like, you can't see anything. So a more appropriate unit would be something called micrometers. And micrometers, I think it's right on yours, look like that. That's the symbol. It's a funny looking U with a little M on it, okay? So 1,000 millimeters. Let's see here. Yeah, well, that's true. 1,000 millimeters is a meter, okay? And then 1,000 micrometers is what it should say here, is in a millimeter. Okay, and that's what yours does say that. Your notes are correct. Okay. Now, there's a couple ways you can approach this basically. Um, there's a couple ways you can do this. I'm going to kind of show you what we did in last unit with the moles and the molecules kind of thing. So remember when we had moles here, for example, and I said we're going to multiply it by moles and molecules here, molecules, and we're going to cancel out the moles, yes, kind of thing. So I set up that ratio or that proportion kind of thing, and I multiply by that to get rid of the units. I'm going to kind of do the same thing for this. I guess you can also think about it this way. If you're at millimeters here, okay, we'd have to go 1, 2, 3 steps down to a micrometer. So that's 10, 10, and 10, basically, or move the decimal. If you're going down this chart, you'd be moving the decimal 3 places to the right, okay? And if you were here, and you wanted to go back up to here, you'd be moving the decimal to the left, and you have to move it 3 places to the left in that case, okay? So it's kind of up to you how you want to do this. I'm not going to say this is right or wrong, but I'm going to show you kind of like I said, we're going to use a ratio. We're going to use this ratio. 1 millimeter is 1,000 micrometers. That's the ratio I'm going to use every time, okay? And again, as you know with the moles and the molecules, you might want to flip that over. It depends on what you're starting with, yes? So maybe I want to put the 1,000 micrometers on the top and the 1 millimeter on the bottom, okay? So it all depends. This is kind of, I'm more worried about this because this is probably what we need to use if we're looking through a microscope. We're either going to be talking about millimeters or micrometers, okay? So, example 1 here. How many micrometers are in 2.5 millimeters? So again, I would say, okay, well, 2.5 millimeters. And I'm going to use my ratio. I'm going to say, okay, 1 millimeter is 1,000 micrometers. Where do I want to put the millimeter? On the top or the bottom? Ben? Bottom. So 1 millimeter is 1,000 micrometers. Does that make sense? Is that good? Okay. And I do that because I want to get rid of millimeters and millimeters. Yes? I want those two to cancel. So I guess, again, it makes sense. 2.5, I'm going to move the decimal 3 places to the right. 1, 2, 3, or 5,000, same thing. And I would end up with what? 2,500 micrometers. That's a micro there. Micrometers. Okay? Is that good? All right. Questions, anyone? 2? Okay, again, I'll actually get maybe I'll get you to do this one. If we have 0.025 millimeters, what's the size of the field of view in, again, this should be micrometers here. I think it is on yours, but. Okay. So in this case here, we want to, this is the number we're being given, 0.025 millimeters, and I want to change it into micrometers. So again, I want to put my millimeter down here. 1 millimeter is 1,000 micrometers. So same deal, okay, those two will cancel, and I should get what, 25, yes? Micrometers, okay? Good, pretty straightforward, I think. Same example as last one. And number 3, okay? So it says here a single cell has a diameter of 5 millimeters. What is the length from end to end in millimeters? Oh, sorry, 5, it should be micrometers, it says on yours, right? Right? That's what it says there, okay? They want to know how many 985, if I had 985 cells lined up all in a row, what's that length, basically, okay? So there's a couple things you can do, it depends, okay? The first thing I'd say is, well, if one cell has a diameter of 5 micrometers, and we have 985 of them, I'd say, well, let's take 5 micrometers and times it by the 985 cells, and that should give me the overall length in micrometers, yes, obviously. If this one's 5, and if we did 985, we multiply those two together. Let me see if I can do that in my head here. Just give me a second here. what is that? 2 and 4, 4925. Is that right? Okay. So 4,925 micrometers. Okay. For those 985 cells. That's how much space it would take up. They want the answer in millimeters. So the next thing I would do is say, okay, well, now I'm going to take that number and I'm going to change it back to millimeters. So how do I do that? Well, 4,925 micrometers. And I'm going to use my ratio as always. What goes on the bottom this time? Micrometers, right? And I know that in 1 millimeter, there's 1,000 micrometers, yes? So I want to flip those numbers over in this case so that, and the units of course as well. I mean, 1 millimeter always goes with, one goes with a millimeter, 1,000 micrometers. And then the reason I do that, of course, is because those units are going to cancel. So really it's 4,925 times 1 divided by 1,000, which should be 4.925 millimeters. Okay, good. Questions, anyone? So that's just kind of playing around a little bit with conversions. Okay, good. Now the next part, and the last part we have to talk about with some examples here, is something called the field of view. Okay, and the field of view basically represents, and it doesn't have to be right here, okay, but this is what we call the field of view. How much of this object can you see, or how much do you see in that eyepiece? Okay, that is set for you. It is set based on the eyepiece and the objective lens you use. So I'm going to tell you right now, when we go to the lab, okay, our eyepiece is 10 times. The first objective is 4 times. So you are magnifying something 40 times. Once, I think it's 4. I'm pretty sure it's 4. Once you set that, once you figure out what that field of view is for this, which we're going to do in our first lab, it's always the same. It can't change because we're stuck at 40 times, right? So whatever you decide on day 1, what is that field of view going to be with these two, with the eyepiece and the objective? You're looking at something 40 times. That's how much space you see. There's no varying there. That's it. And then once we figure out 40, we can also figure out 100 times, maybe 1,000 times, okay, or whatever. But they're always going to be the same values because that's how much you're, even if you didn't put an object underneath there, if you had an imaginary something or other there, if you had nothing, that's what you're going to see, that much, okay? So this is the field of view. Obviously, it could go this way too. This is also the field of view, right? Anywhere there. We usually go left to right as the field of view. It doesn't matter, okay? So how do you measure field of view? This is going to be one of the first things we do, okay? Because we need to know the field of view. We need to know how much, what are we looking at? How big is this object, okay? On low power, we're going to focus on the millimeter markings of a clear plastic ruler. We're actually going to do this, okay? So, on low power, okay. On low power here, I want you to take a look at this, and I think you have the same diagram there, okay. How much can you see on low power? What is the field of view? What do you think? If you looked at this clear, it's on your sheet as well. How much do you see? Yeah. 1.3 millimeters. There's the other dash probably right about there, yes? And I would estimate that to be about 1.3. Good enough, okay? So on low power, this would be 1.3 millimeters. Do you know what happens on medium power?
Not yet.
No. What will happen on medium power, do you think? I know this is kind of a little bit, maybe we're not sure yet. Yeah? Huh? It gets zoomed in. What are you going to see on medium power? You're right, absolutely. It gets zoomed in. Yep.
That 1.3 millimeters is going to go down. It's going to be like 0.6 or possibly even lower.
Okay.
It's going to be lower than 1.3.
You know what you're going to see? Probably nothing. because once you zoom in, you will actually be in between here, okay? So when that happens, the answer is this. Listen, when you go to medium power and you're like, what's the field of view? I don't know. That's why we have a formula to do this, okay? The only thing you're going to see on low power is this. You'll see this on low power. After that, there's no amount of manipulation you can do with the microscope to see the field of view. You're not going to see anything because it's going to be between the millimeter markings, okay? So you have to use a formula to calculate it. And what do you think is going to happen on the highest power? You're definitely not going to see anything, okay? So again, the ruler's useless at this point. People always want, and listen, I'm telling you, people always want to, oh, well, this is what it looks like on low power, and then they switch it to medium power, and they're like, I don't see anything. Try high power, maybe that'll work. No, it's not. You're not going to see anything. If you're lucky, you might see this. You know, you might see the actual dash that takes up the entire screen. What does that even mean? I don't know, okay? You need to use the formula, okay? I don't know how else to tell you. Use the formula, okay? And so we have a, that's not the formula, okay? I hope, right? That's how I feel today. This week, really. Yeah, there's been a lot of question marks in our house. A lot of question marks. Anyway, okay. Anyway, I'm going to leave it there because whatever. But what does it say here next? Okay. For medium or high power, the field of view is generally less than a millimeter. So a ruler cannot be used. Instead, we have to calculate it. Okay. And then, I don't know, okay, that's the formula right there, apparently. And it looks a little something like this. Ready? That's not it, okay? That's, like I said, that's kind of how I feel this week, okay? The formula looks like this. The field of view, and by the way, I'm just going to kind of abbreviate this, but the field of view, and we're going to talk about high power, okay? So HP. Not the sauce, that's different. Is equal to, okay, the field of view on low power times, and I know this looks a little crazy, but I'll explain what's going on here, times the low magnification over the high magnification. Okay. All right, yeah.
Is there measurement devices that have micrometers on them?
Oh, yeah.
Like a ruler that has micrometers or something like that?
It's usually not a ruler. It's called a micrometer.
Or would it just look like a ton of black lines?
No.
Like you couldn't really see the spaces?
You can see the spaces. It's called a micrometer. Micrometer. It's basically got a little dial, and it basically moves very skinny. It'll measure the thickness of the paper. And you just kind of, you clamp it on, turn it, and it's kind of like a U-shape. Well, there's different ones, but the one that I have is like a U-shape kind of thing, and you just tighten it up until it grabs on either side. The divisions are, because you're turning it so small, the divisions are made for that. Okay, good? All right. So that's the formula. It looks a little confusing, but our low power would go here, okay? Our low power goes here, so maybe, for example, if I'm on low power and it's 10 times, that would go there. And let's say I'm zooming into 100 times, that would go here, okay? So this has to do with the powers on the microscope right here. Right here. Yeah. Those are the powers of the microscope, okay? The lower one goes on top, whatever the lower number. Maybe you're doing 50 and 100, I don't know, okay? If it's an example, it could be anything. If we go to the lab, it's going to be the lower power one, whatever that is, and then the higher power one. You can do 10 to 100, you can do 50 to 100, you can do 25 to 100, you can do 100 to 1,000 if you want. I don't care. It's the lower one and the higher one, whatever that happens to be, okay? This is how much you're going to see on low power. So, for example, in our example that we just looked at, this would be your 1.3 millimeters. Okay, that was on low power, it said. Okay, and then what do you want to know on high power? That's what you're going to calculate here. Okay, now again, you could solve for any one of these things, but I'll kind of show you what's going on here after a couple of examples, and then you decide how you want to figure this out, or if it makes sense to you. Okay, so let's just take a look at this one first. Okay, the field of view using a 10 times objective lens is 2.5 millimeters. What would be the field of view if a 40 times objective lens was used instead? Okay, so if you think about our formula here, I'll use the formula first, and then you decide what's going to work for you. Okay, this looks complicated, but let's write down the formula. I'll give that to you on the quiz or the test eventually someday. Start with the formula. And of course, that's the magnification. Maybe I'll write that down for this one. I tend to kind of, after a while, I kind of forget about that, I guess. Okay? So listen, let's go ahead and fill some things in here. Okay? The field of view using a 10 times objective. 10 times objective. Okay? What would the field of view be with a 40 times objective? Where does 10 and 40 need to go? We're talking about the objective lenses here. Where do they go?
Low and high.
Low and high, yes? That is, basically I'm going from 10 times to 40 times, yes? So I'm going to put in here, right here, 10 and 40. I'm going to skip the times thing because there's going to be too many timeses in there, you know what I'm saying? And then we're going to get confused about all the timeses. But it's 10 to 40, right? That's what we're doing. And how much can I see? Now here's the key here. The field of view using the low one here, this is the lower of the two, yes? The field of view is 2.5 millimeters. Where does that go? Here or here? Here? Here. Yes. Okay. Field of view using the lower power is 2.5 millimeters. Okay? And again, we're solving for this. What is the field of view on the higher power on the 40 times objective? Okay. And the answer is, well, what's 2.5 times 10? That's 25 divided by 40, or a quarter. I got this. Don't tell me. I can do this. 2, 25, 40. 0.675.
5/8. I don't know if that reduces.
It's 5/8.
5/8 is the.
Yeah, it should be 0.625. 625, yeah. So it's 0.625 millimeters. Okay. They didn't say to change it into anything else, but that's what I would end up with there. Okay, 0.625. Now, maybe that's we'll do a couple more like this, and we'll chat about this for a second. Well, maybe we could chat about it now. We can do that. So, question. Okay, look, if you look through it and you're on low power and you see this much, right? Let's say it's this much, whatever. That's the 2.5 millimeters. Just go with me. 2.5. What happens when you zoom in? You're going to see more or less. You're going to see that, right? So the field of view gets less. Yes? Do we understand that? Okay. How much less do you see? Well, there's an easy way to figure that out. Just think about it. If you're going from 10 to 40, you're zooming in how many times? 4 times. Yes? if you zoom in 4 times, does it make sense you're going to see 1/4 as much? Right? You're basically going from here 4 times, and you zoom in 4 times, or 4 times, you're going to see 1/4 as much. Yes? That's what this does. Look, is that not 1/4? Yes? Really, when you break it down, that's 1/4 as much, right? You zoom in 4 times, you see 1/4 as much. You zoom in 8 times, you will see 1/8. Yes? You zoom in 100 times, you'll see 1/100th as much, right? Because you're zooming in from here to that, right? That's what's happening. That's all this formula does, okay? So don't think that this is like super complicated here or anything like that. That's what's happening. What happens if you go for something like this and you decide, oh, I'm going to zoom back out? Boom, like that. Well, it's going to get 4 times bigger, or 8 times bigger, or 100 times bigger, or 1,000 times bigger, or whatever, right? And again, that's all that that's doing, okay? The difference would be you'd be kind of having some numbers over here. So we can kind of get wrapped up in the formula, and that's fine, because some of you guys need formulas, and that's good, okay? And you want to solve for this or that or whatever, that's fine. But we also have to think about, okay, when I zoom in, things are getting smaller. They're getting smaller by the factor that I'm zooming in. 10 to 40, that's a 4 times factor. If I'm going from 10 to 40, I'm zooming in 4 times. I'm going to see 1/4 as much, 1/4. Okay. The field of view is 2.5 millimeters at 1,000 magnification. What would the field of view have been at 10 times magnification? So I'll use the formula again here, but some of you maybe already can tell me the answer. Oops. Times low over high. Okay. Now, you really have to pay attention to the question, especially if you're going to use the formula. So look, these are my 2 times, those are my magnifications, yes? 10 and 1,000, okay? So we have to understand, okay, which one's the lower one, which one's the higher one? It's not your question. 10's lower, 1,000's higher, yes? So if I was going to do this, I would say this is 10 and this is 100 here, or 1,000, sorry, okay? 10 and 1,000, yes? Right? Yeah. Oh, does it? 10.
Yeah, instead of 1,000.
Okay. And it's 2.5 micrometers? Is that right too?
Yeah.
Okay, my bad. We'll change it then. That is what it says? Okay, sorry. Remind me, I'll try and switch that. Okay, better? Yes? Okay. Where do I put the 2.5 micrometers? Where does that need to go? Does it need to go here or there? Is it on low power or high power that I see 2.5 micrometers? Okay, look at the question again. This is being combined with this. Okay, which means what? That's going to be high or low? High, yes, in this case, because the 100 is the high magnification, low is 10. So if that's going to be with the high, that's actually this number here, right here. So again, you want to make sure that you know where these numbers go, which of course would be what? Field of view on high power equals the field of view on low power times the low and the high, right? And we've established that this is 10 and this is 100. And we would put the 2.5 probably here, yes? Micrometers, because that's what you see on high power. This is where it becomes a little difficult if you're not great at math and fractions and stuff. This is where things can get a little complicated because you kind of have to solve for the field of view on low power, yes? And to do that, okay, what I would maybe suggest is maybe putting the numbers in, perhaps. Or, look, if I want to get this over to this side here, I kind of have to multiply by the reciprocal of that. Does that make sense? Like I would multiply, look, if I want to get rid of this and just isolate this part here, I would do high over low so that those cancel. And I would do over here high over low, okay, and multiply it over here. Or basically say 2.5 micrometers, 100 over 10. And that would be the field of view on low power, which of course works out to be, what is it, well, 1025, yes? I'll explain this in a different way here right away. So that would be 25 micrometers would be your answer. And that's a little complicated, I think. That's a lot of work to kind of get that, but that's the math of it anyway. Okay? And that looks a little confusing. Let me just go back to here. Oh, sorry. Is everyone okay with that? Like, you copy that if you need to or whatever? Okay. Now, here's the deal, okay? And I don't care how you want to think of this, but you can also do this. I mean, do you have to use the formula? No. Just make sure you understand what's going on here. So let me just reiterate this. It's 2.5 micrometers at 100 times. Okay? Okay. What's the field of view at 10 times? At 10 times, what is this? Okay? Now you have to think about what's happening here. If you're going from 100, I can't set you up a ratio and proportion thing here and make this all pretty because it's kind of, it's not a direct proportion. It's not like when the magnification gets larger, the field of view gets larger, it's actually the opposite. It gets smaller, right? Does that make sense? So I can't set you up a little fraction here of equivalent fractions to make it all nice. What you have to think is, okay, if I'm going to go from 100, so just think of this. I'm zoomed into 100. I see this much. If I back it out to 10 times, my field of view should get bigger, yes? How many times does it get bigger? 10 times, right? So if it's going to get 10 times bigger, it should be 10 times that much, yes? Which is 25. Yeah? Okay? It's kind of an inverse thing that's going on here. So again, I can't set up an equivalent fraction, but if you want to think of it that way to get the field of view, I don't care. Okay? Because I know the formula is kind of confusing a bit, and there's a bunch of like letters and stuff, and then you got to multiply by reciprocals, but that's what's happening. Look, if I went in, or the other way to think of this is if I went from 10 to 100, right? I'm zooming in 10 times, so this number has to be 10 times smaller than my other one, yes? If I'm zooming in 10 times. You can look at it a couple different ways, I don't care, but you know, on the higher power, you're zoomed in. It's going to be small. On the lower power, it should be bigger. Okay? Last one here. Again, 4 times objective lens is 5 millimeters. 40 is the other key part here. Okay? What is the field of view? Don't worry about this part yet. We're not there. Okay? We'll worry about that in a second. We just need to first of all find the field of view. And again, okay, it's up to you. But look, if you want to make a little chart for yourself, at 4 times, I see 5. Is it 5 millimeters, or is this the actual question here? I better double check, eh?
Yeah.
Okay. At 4 times, I see 5 millimeters, yes? At 40 times, I'm going to see how much? And the answer would be what? Well, 4 to 40 is the factor of what? Huh? 10. Right? 4 to 40. That's 10 times zoomed in, so I'm going to see 10 times less, right? Or otherwise known as 1/10 as much, yes? So what's 1/10 of 5? 0.5. Make sense? This, and I can do this for you. Look, that is 10 times zoomed in, yes? 10 times. So if I want to look here, that's 1/10. Yeah? Okay. You're zooming in 100 times, 1/100th. Okay, etc. Now, let's talk about this. If an object takes up 1/8 of that field of view, how big is that object? In other words, if it only takes up, if you're looking in there, it's only like this little section. Okay. Here's my field of view, and I break this up into eighths. Eighths. If I break it up into eighths, my object only takes up, like, my object right here, it's only that much. How big is that object, kind of thing? And the answer would be, well, it's an eighth as much, yes? Okay? It's an eighth the size. So 0.5 millimeters times 1/8. The object doesn't take up the entire field of view. It takes up only a small little 1/8 as much. So what's that? Let's see. Oh, geez. I'd have to do some math on that. I don't think I can do that. I'm barely breathing right now. I don't know. What is that? Somebody? It's 0.0625? Yeah, I knew that. Millimeters, okay, would be the field, would be the object size, okay? Or we could say 62.5 micrometers. Okay, yep.
Would it also be okay if we wrote it in the fraction form of 1/16 millimeter? Or do you want the decimal?
Oh, I don't care. Usually we'll go with the decimal, but if you want to put that, that's fine. I don't
Or
care.
we wouldn't lose much.
No, that's fine. Half of that, yeah.
In our question, it says, what would the field of view be? You know how it says millimeter?
Yeah.
Ours it says micrometers. So when you have to convert it,
Mm-hmm.
so it would actually be 0.
Oh, it's
3
in
zeros.
micrometers? Okay, so in this case here, it'd be what? What's this in micrometers? 500, yep. So 500 micrometers, and this would be 62.5 micrometers. You're going to get the same answers, just in micrometers instead. Okay? Just obviously just convert them, right? So I can do that. 500 micrometers, and this would be 62.5 micrometers. Okay, good. Questions, anyone? Okay. I do think it's really important that you try these questions because this is kind of what your first lab is going to be based on here when we go to do that. Okay. That was a long